Hi, my name is Holly Dedridge. My student number is DUD13001480, and this is my Nutrition 1 assignment. Okay, so first of all, we're going to go through the 7 nutrients. First of all, we have carbohydrates, proteins, fats, vitamins, minerals, water, fiber. That is it. First of all, we're going to discuss carbohydrates. Carbohydrates are primarily the source of energy we get from our food, and this makes up around 50 to 60% of our daily diet. However, this is totally dependent on some sports like long distance running and athletes such as Mo Farah, which would ideally require a higher percentage of carbohydrates. An example of this would be kind of around 70% mark. When we consume particular food with a carbohydrate within it, it provides us around 4 calories for every gram in the carbohydrate. The role of the carbohydrate itself is to supply the body with a main source of energy before, when the carbohydrate is used, it is converted into glucose. But when we do not require its use of the glucose is stored to become a source of glycogen. So simple and complex carbs. Simple carbohydrates. Simple carbohydrates are mainly sugar, when the carbohydrate structure mainly consists of 1 or 2 molecules, one called fructose glucose, which are monosaccharides, and 2 molecule carbohydrate is formed of the lactose, so sucrose, which is the disaccharides. These are the quickest source of energy and are generally hard to digest. This is mainly because they are broke down at a rapid rate. Some of the simple carbohydrates are molasses, brown sugar, and soft drinks. Complex carbohydrates are known as polysaccharides. These are good carbohydrates which will primarily be included within someone's weekly and daily diet. The structure of complex carbohydrate is different to the simple carbohydrate because in a string of molecules that resemble a necklace. These complex carbohydrates are usually rich in fiber and therefore are more filling than a simple carbohydrate, sugar due to the nutrient density of the actual carbohydrate. Complex carbohydrates are normally found in whole plant food, so therefore they are also high in vitamins and minerals. An example of this is of a whole plant food that have complex carbohydrates are green vegetables and whole grains such as oatmeal and pasta. Carbohydrate percentage. The carbohydrates are primarily stored in adipose tissue. Muscle storage is about 325 grams of glycogen storage. The liver has 100 grams of glycogen storage. Blood glucose ranges from 15 to 20 grams of glycogen storage. Now we're moving on to proteins. The main cause for proteins is to help grow and repair muscle fibers when they are damaged. They are also considered as another energy source, but these are only in extreme cases where the body has to use this in kind of a survival mode in order to burn off some energy to keep us alive. This makes up approximately like 15% of our diet. The protein in our body is made up of 20 amino acids, which we all use all of them. 8 of them are essential. This means these amino acids cannot be made by the body and they must come from food. And 12 are non-essential, meaning they can be synthesized by the body itself. Foods that contain 20 amino acids are considered to be complete proteins. Fats. The roles of fats. One of the roles of fats is the protection of internal organs, storage of fat suitable for vitamins, a source for energy production, thermoregulation, classification of fats, saturated fats, An example of a saturated fat would be butter, margarine, lard, processed salty meat, chocolate, coconut, and biscuits. Polysaturated fats. Example of a polysaturated fat would be soft margarine, safflower oil, fish, nuts, and low-fat spread, flaxseed. These are kind of much healthier components in comparison to other saturated fats, which are mainly processed. Monosaturated fats. These are probably the most healthiest for you out of all the three. So this would be olive oil, liquid form and spread, peanuts, peanut butter and oil, and rapeseed oil. Vitamins. Vitamins provide us with energy. Vitamins are classed as a micronutrient. There are two types of vitamins. So we have water-soluble. So this means that the vitamin can be successfully dissolved within water. Fat-soluble. This means that the vitamins can be dissolved in fats or oils. And here I have constructed a table. The vitamin and what kind of vitamin they have are the types, so what it is. It can either be fat-soluble or water-soluble. The function of the vitamin and what it helps. The source is the category for where you can find that particular vitamin in, and the kind of downsides if you don't consume enough of this, and what will happen to you if there is lack of this particular vitamin. So an example of this would be vitamin A. So you'd have a 0.7 milligrams of this. The type of what kind of it can be soluble in is the fat soluble. The function of the actual vitamin, of vitamin A, is help sight, bones, teeth, skin and hair. The source and where the vitamin can be found are in dark green vegetables and carrots. And the deficiency, if not you don't have enough of these vitamins, would be reduced night sight and poor and dry skin. So moving on to minerals. So there are two main types of minerals. We have microminerals. So these are often referred to as trace minerals, and this is because they are currently present in small doses inside the body. These are required in small levels of within our daily diet. An example of this would be a micromineral is iron and zinc. Macrominerals. These are present in larger scale doses in our body and are required in larger doses in our diet. These are components like calcium and sodium. Again, I have constructed another diet of the mineral, the type, function, source and deficiency. So, for example, first of all, we have zinc, which is 12 to 20 micrograms. The type of mineral is micro. The function of the mineral is assist in carbon dioxide transport. The source and where you can retrieve this mineral from consumption is cheese. The deficiency of not having enough zinc is reduced respiration. So fibre. So first of all, we're going to discuss what fibre is. Right. Fibre is a complex carbohydrate which is also classified as a starch polysaccharide. It is not digested. A healthy diet types of fibre, adults need approximately 18 milligrams in their diet intake. There are two types of fibre. Insoluble. This is a liquid that cannot be dissolved into and is not fully capable of forming solutions. Soluble. This is a substance that is able to be dissolved, especially in water. Here I have constructed a third table for fibre. So, for example, we'll discuss the type, so insoluble, and the role is that it does not dissolve in sources that include pasta, rice and whole grain, and the function of this will be to prevent bowel disorders. Another type, soluble, dissolving in water. Sources in water include fruit, vegetable and oats, and the function of this is can prevent the intake of nutrients, controls blood glucose and cholesterol. Water. Water content. Water makes up around 50 to 60% of our body weight. Muscle has a higher content in water than in fat tissues. Therefore, leaner individuals have a higher water content than individuals who are slightly overweight and have a higher fat content. The roles of water: responsible for the transport of nutrients, used for temperature regulation, aids the passage of food through the digestive system. Food sources extracted from water content. Another table that I have yet constructed: the source, fluid, so that's drink, milliliters 1200, food 1000, and metabolism 350. So here I'm going to do a comparison between a marathon runner to a weightlifter. So macronutrient to a marathon runner. Carbohydrates for a marathon runner depend on how long the run is for that day. If the day is easy, for an example, if the run lasted about 30 to 40 minutes, then the intake of carbohydrates would be 3 to 4 grams per kilogram per body weight. If the run lasts for over 120 minutes, then the intake of carbohydrates is 8 to 10 per kilograms of body weight. The amount of the carbohydrates is much needed in the marathon runner's diet plan because the carbohydrates, once consumed, are converted into glycogen, which are stored in the muscles in order to provide the muscles with the energy. Proteins and fats. As well as the carbohydrate intake that takes over the most of the bulk in the diet than the energy, the runner also requires a fair amount of proteins and fats as well. It is suggested by researchers that marathon runners need 50% more protein in an average diet so that the marathon runner can use more energy. The amount should be 12 to 15% of protein's total calorie content, and around less than 30% of calories should come from fats. The marathon runner needs to ensure they consume the right amount of fat and eat it before they work out, and fat takes the longest to digest. Second comparison, micronutrient from a marathon runner. Vitamins that would be needed for a marathon runner would be vitamin B. This is because the vitamin's role is to provide a source of energy which the athlete requires, so it's slow releasing and can be used in the duration of exercise. The source of the vitamin is based in meat, milk and vegetables. This is a positive because the marathon runner needs to consume 50% more protein than someone who didn't do exercise anyway, so they will receive a lot in that particular vitamin anyway. Iron is one of the best minerals for a runner. This is because it helps in the production of hemoglobin. If there was too little iron in the blood, then the energy levels would decrease, and then the individual's performance levels would drop. Weightlifters also need a specific amount in order to be aesthetically and physically successful. The amount of carbohydrates a weightlifter needs is approximately 1.5 to 3 grams per pound of body weight per day. This is because the bodybuilders need to have the carbs to convert into glycogen into their muscles, so they have the correct amount of energy so their muscles don't fatigue. Bodybuilders also need around 1 gram of protein per pound of body weight of protein. The reason for this is because the body needs the excess amino acids through the day so the muscles that grows back is nice and lean. The reason that they need this amount is because they need the protein to repair the damaged muscles so it can grow back bigger and stronger, so it benefits them physically so they can lift heavier weights. Weightlifters need approximately 10 grams of fat per pound of body weight per day. This is because the fat is the energy source and going to provide the weightlifter with strength, and the correct intake determines how strong it will be. Vitamins and minerals that are good for a weightlifter. Vitamin D is good for a weightlifter. This is because the function of the vitamin alone promotes strong bones and assists them in muscular contraction and calcium absorption. This is good for a weightlifter because they need to have strong bones and a good rate of contraction, as they need to maintain a good grip when handling hard weights. The mineral calcium is good because it also promotes healthy and strong bones and the formation of the bones, so the weightlifter can have a strong bones to take the pressure of the weights they are dealing with. Water for a marathon runner and a weightlifter. Marathon runner. Water is essential to life and keeps our bodies functioning. We can last for weeks without food, but only a few days without water. Marathon runners are recommended to consume 400 to 800 milliliters per hour during a marathon, so that's 13 0.5 to 27 fluid ounces. If the marathon runner does not consume enough, they will suffer dehydration, which